Okay, so now we are doing today's code forces contest. Let's see. So this is the yeah first problem. Code forces round 851 div 2, right? So happened on like 9/2/23. So first question, one or two, simplest question of all, obviously. Your t number of test cases are the number n just given to you, and the second line contains the like those array elements, right? Now you have to tell a particular index, like what is this? Basically, you have been given a sequence a1 to a, and basically the array given to you, and you have to find an integer k. You have to return that k such that the conditions are met. So k is basically an index from 1 to n minus 1, and the product of elements from a1 to ak is equal to the remaining product, which is a plus k plus 1 to a of n. Yeah, so that is it. Basically, you are given a array. You need to see a point where the product of prefix is equal to uh, not prefix, but yeah, where product of the left side element is equal to product of the right side element. So you can do brute force, like calculate the total product and see. But what I did, basically the problem is more simpler because the array elements are just one or two. So how I counted the total number of two present in the array, because one is not contributing anything to product. So let's say if this is the test cases, let's see. Yeah, so if this is a test case, in this case, how many twos are there? Four twos are there. So number of twos are even, so answer will be possible. We'll see that. So in this case, two is only one, so answer will not be possible because this the product is two. You have to divide it into two segments. Look, basically, just see that when the two is just one, you cannot. You should have like same number of twos over here. Let's say x number of twos, x twos, and then you should have like x2s on the left hand side and right hand side. So the frequency of 2 should be even in the array. If it is odd, we can just directly return minus 1 or no, whatever. And if it is odd, then you need to see a point as point, let's say point x, where the number of 2's before it is equal to number of 2's after it. So that is your answer. So how I did it, simply like just I traversed to the array and firstly store the map. So I'm not coding this up, just telling the logic and then show you the code. Store in map the frequency of 2. Basically create a frequency map. Frequency of 2 just gets stored. You can just use a variable also, and then a iteration. The second step is iterate on array to see current count of 2. Take a current count of 2. You're iterating from left hand side, so your counter keeps on increasing as soon as you see 2. Now if like when your c becomes equal to, so first of all, over here you can just see if your total count of like map of 2, total frequency of 2 is odd, then you can just return no or minus 1, whatever. So now when c is equal to m of 2 divided by 2, which is total frequency of 2 divided by 2, you can just return that index id, that return that index. Okay, so you can use while loop for this matter, like iterating on this array instead of just for loop. You can use while loop id is lesser than n if current element is equal to 2. You can just say c plus plus, and if c becomes equal to m by 2 at any point, c is equal to m of 2 by 2. Like m is basically map I use, but I think you can just use a single variable to store a frequency of 2, or you can say total frequency of 2, fr of 2 divided by 2, and then you can just say that index, return that index, like see out that id and break out and break. Okay, yeah, and that's all. like uh like if it was odd, you just returned minus 1 before that. So this is the answer in case of even. So let me show you the code for this one. This is the A, right? Submission accepted. And this is the one, right? So I created the map as I told you. Like you could just use a normal variable to store the frequency of 2. And then total is equal to frequency of 2. If that is odd, then you return minus 1. Else if that is even, C is equal to 0. And C, and then C the total count, C plus plus, and then M of 2 divided by 2 equal to then I plus 1, and then break, right? So whenever this becomes equal to m2, the total frequency of 2 divided by 2, you just break it and print that answer, right? Now let us see the problem number B. Yeah, D was an interesting problem actually, so we'll cover two problem in this and then C problem in the next video, right? Whew. Now This is also a pretty easy problem. You have been given t number of test cases, a number n given to you, and you have to print two integers x and y such that their x and y should follow two condition. One is that the sum of x y should be equal to n, the given number, and then you have to what is sum of digits. You know the sum function of sum of digits. You can calculate the sum of digits present in a number x, right? Any integer you can calculate the sum of digits for x, and you can similarly calculate the sum of digits for y. So it would be in the range. I'm not discussing in what range it would be. For example, n is 10 raised power 9. So the biggest number can be 9 into 8 times, right? 8 times 9. So 9 into 8 or 9 into 9, something like that, right? Yeah. So, yeah, so basically that is the sum of the digits, and then basically x and y, the two numbers which you are forming, their sum of the digits should not differ by greater than 1. So there's sum of the digits you have to find out, and then it should not differ by 1 at most. So let me show you, like, simply there are some, again, edge cases kind of a thing. Yeah, so for I'm saying, like, for even elements it's very simple. For even elements, because n is equal to even here. So you have, let's say, n by 2 and n by 2. These two number are like exactly equal, and their sum is equal to n. So if the numbers are exactly equal, the sum of digits will always also be exactly equal. So in case of even, you can just return that. In case of odd, you need to like, think thoda sa. And but the in case of even, it was really simple, like n by 2 and n by 2. In case of odd, let's say, now there is a two cases of odd. Like, one is the normal odd numbers tree, and there is a other case for special odd numbers. These special odd numbers are in the form of 20k minus 1, okay? 20 into k minus 1, like, which are having a remainder of 19 from a 20. Or you can say the numbers instead of this normal odd numbers, and then there is a odd numbers are basically ending at, end at 1 3 5 7 9. So normal odd numbers are these ending at this, and special odd numbers I'm calling out as the ending at end at 9. Okay, it just end at 9. So how I'm saying, why this is a special, you have to deal. So otherwise, if it is a normal odd, then you can say ki n by 2 comma n minus n by 2, the remaining part. So these two number would be summing up to n, right? And I'm saying that like, if they are ending with this, so these two number, the sum of digits, if you find out, it would also be, good. Like, it would be just yeah, one different, because, like, let's say our number is like 77. So 77 divided by 2 would be how much? 36? No, no, no. 26, no, 33, I think. No, 76 divided by 2 is equal to 38. So 38 and 39 is this, right? So 38 and 39, as you can see, the numbers are forming 77, I hope, right? And then their sum of digits are also just, yeah, the sum of digits for this is 11, for this is 12, which is just, the difference is 1, right? So it's fine. But the point is that, what is the point? The only point is that when there is a number like 79 or 799 or 7999, so what you have to do, if you divide it into two parts, so it would look like 399 and 400, right? 399 and 400. This is exactly how it look like. So this has sum equal to, let's say, 1215, and this has sum equal to, sum of digits equal to 4, which is not at all good. Like, otherwise, if it was like last digit is not 9, last digit is 5 or 7 or 3, or then it would be very easy for you. So like 3, or you can say 392, or too bad. Other part would be 304, I think. The half of this is what, yeah? The half of this is 300 and 400, something like that. So let's say 400, and remaining part would be 395, right? 395. Now I'm just finding out that point, right? Okay. 40, let's say 396, 3 and 401. This is summing up to, okay, so no, no, no. 399 or what, like 400 and 396 is not good. 399 and 396 is fine, I think. Now 398 and 397 is perfectly fine, right? If you sum them up, they would be equal to like the current thing, and this is also fine. The sum is equal to this, and the sum of digits is also just differing by one. So what I'm saying, the all the numbers which have ending at 9 are being special. So how you'll tackle this 15 and 4? So like the approach, like this is the just one liner approach which you need, like observation based approach, like the some code forces problem. So 99 you have to consider. So 99, how you have to consider 99, you have to say I'm breaking down 99 into two parts. One is like 5 4 and this is 4 5, such that the sum of digits is same, and 99 can be broken down as this. So if there was just 9, I would break it down it as like 5 and 4. Why 5 and 4? Because I know this number is smaller, this number is bigger, right? So this is 3 and this is something like, this is 4 and this is something like. So now I'm splitting up this 99 into both the things, like this part and this part. So creating this as 54. Why 54? Because 5 because like in this case there is equal amount of 5 and 4, so 45. So this would sum up to 99, I think. Yeah. So now like when there is odd number of nines, right? Odd number of nine. So let's see, if there was 3 triple nine and 4 triple zero. Okay, so yeah, for this matter now there is three nines, right? So there is 3 and some digits you will be giving up, and 4 and some digits you will be giving up, so that they become closer, not exactly closer, but such that their sum of digits become closer and their sum should be always constant. So you're splitting this 999 into these two parts such that the sum of digits is being optimized, like be close. So for that matter you will do 545 over here. Why 545? Because this 3 is already lesser than 4, so you want to give it uh like, yeah, more sum of digits, so you have to give it more number of 5. Instead, you have to give him more number of fours. Why you have to give him more number of fours? Because this is already having one four. Like this is already a greater kind of a number, like 4. Yeah. So this is the logic, all logic which you need to think, like 545, and always like 5 and 4 gives you 9. When you have two digit like 5 4 and 4 5 gives you 9. When you have three digits like 5 4 5 and 4 5 5, so alternating 5 and 4 you have to give to both the numbers, right? So I'm just giving to one number, and the other number you can just directly find out by subtracting that from the original number. So that is my logic. So should I code it? I think we can code this up, because there are two or things important thing to note which I think you will understand while seeing the code. So first of all, the good thing about this, problems are simple in terms of input. Yeah. Now, if n is or even, then also it's very good, right? Equal to 0, then you have to just return. I think you have to print yes or no, or you have to print what? No, you just need to print directly the numbers. Answer is always possible, I think. Yeah, n by 2. And then if it is odd, then there are two cases. Two cases are like, how can I describe? Two cases are like the ending number is 9 or not. So for that matter, int a is equal to, let's say, n by 2, b is equal to n minus n by 2. Now you have to consider the sum of d1 and a and b. So I'm creating d1 is equal to 0, d2 is equal to 0, sum of digits for a and b. Also temp1 temp2 to not hampering a and b. Temp1 temp2 is equal to b, while your temp1 d1 P1 divided by equal to, let's say, A or what, 10, and D1 plus equal to your T1 divided modulus 10. Okay. This is the remainder. Basically, this is the sum of digits I'm calculating. This is the standard way for that. Okay. So T2 plus equal to T2 plus divided modulus 10. T2 divided by equal to 10. So that's about it. T1 and T2 and D1 and D2 is now the sum. like not the yeah dn is the sum of digit, d2 is sum of digits for b. Now you need to see how many, like if it is, if it is in this form, like there are some 999, then it would be like this form, like other number, there would be some number, let's say x, and there would be some number, let's say y, and there would be some number of digits, any number of digits, like there would be anything, it can be, but at last there would be some nines, and it can be it would always be zero, like not always be zero, but let's say some numbers, and then the same number of zeros over here, the same number of nines and same number of zeros. So this is a kind of a, like, identify the question. Yeah, first you have to find out the total number of 9 in the ending part of a. Yes, in the ending part of a. How you will do that? So int count equal to 0. So while sum of digits like d1 or less 10 is equal to 9, so d1 divided by c plus plus what I'm doing, and d1 divided by equal to 10 I'm doing. So now this is all number of 9 you got. Now you need to create 5 for 5 for 5, but also you got the, like you got the remaining part of string. For example, you got this part of string like x37, which you need to have, and there would be 5 4 coming up because there were two nines, and then there would be 4 5 coming up because there are two 4 are two zeros are replaced. So 5 4, so you need this number like x37. How you'll need, how you'll have this current d1 is equal to that, not current, yeah, I think no, not current, एक second, let's see. A part is this, B part is this. I think current D1 would be something, but yeah, sorry, this is a temp one, I think, or temp two. Okay, actually, you can not use temp one, temp two. Yeah, you can use temp. No. Temp one, temp two is now manipulated. So yeah, now you need to use A. This is my A part. Okay, A part, and because you have to count the total number of 9 in the end of this a, and after having this total number of nines in the end of a, this is the counter storing that, so c is equal to that number of nines. Now 5 for 5 you have to do, so d is basically your so use the string to store this, right? I'm saying use the string of s is equal to d, not d, but just to string of d part. Now, no, sorry, current A would be that number. Okay. Now what you have to do, counter you have, you can run your loop from I to counter. I is equal to 0 starting में. I is equal to 0, and counter you have to, you can just start from you can just do I plus plus every time, and you can just say ki if I is modulus 2 is equal to 0, then you have to give out like s plus equal to 5. S is basically my the first number. I'm forming up the first number in this way ki I know that the first digit would always be, you know, lesser than that. That's like x would always be lesser than y, or not even x, but yeah, if this is x37 it will be x38 or whatever, something like that. Yeah. um, yeah, like anything, but yeah, there would be a difference between that, like 38 and 39, not 38 and 39, but yeah, 399 and 400. So this is 3 and this is 4, and there would be some numbers like, let's say 3 329, and the next number would be 330. So in this case 32 is greater than 33, sorry, lesser than 33. So this number you have to give more number of fives. So for s I want to give more number of five, so I'll start giving out 5, and then if it is even, then you cannot do anything. The a 5 number 5 4 would be equal. If it is odd, then you can give more number 5 if you try to give like from starting only, like if you give 5, and then else part is s plus equal to 4. I think it would give you a correct s, and then you will have n minus s. That's all what you need. Now the thing is, like, you have to convert it into string, not convert into integer. Stoi of s, z, and n minus z. Okay, let's check this out. Let's comment all this. Oh man, so much comments, but yeah, no. 01, 80, 81, fine, right? 80, 81 is fine, obviously. And yeah, 164, 80, 81, fine. And 33, 34, fine. 603, 603, fine. I think all are fine. So you can just, there is no case like where you can actually see, but I think 199 or 299 was that case. I don't know. 399 and 400. So 799 is that case. Okay. You will see it not splitting into 399 and 400. Instead, it is splitting into 354 and 445 because 4 is obviously greater. So now currently you can see that sum is not exactly equal. Yeah, but there is a just at most difference of 1 is allowed and there is a difference of 1. So let's sum this up, man. Contest is over. So can I not submit? System testing is being. So I can show you my submission, then it's just exactly same and it's not a lengthy code too. So if it is even, so you can just see out that. Else you form two numbers A and B, and C is basically, what is my C? I don't know. Okay, so C is basically me counting up. Okay. Yeah, actually you don't need the this D2. Why you don't need this D2? You don't need this d2 actually, because you are not doing anything with the sum of this, you just need this d1 to get to know, like, why you need this d1 also. Yes, you don't need that d1 d2 actually. You don't need that d1 d2. I just, yeah, for a you just count how many number of nines are in there a. So those nines you have to like give split out, like other would be like 00 in place of them nines in b. So you have to split out that 9 into terms of 5 4 5 5 4 or something like that. So now calculate the total number of nines, and then remaining part is just as it is, and then now try to give up maximum number of 5 to this one, like the given s. So it's just 54545, and the remaining part would be just forming up as a remaining part, and you can just try to sum this up. So this is the main logic. Count the total number of nines in the ending part of, let's say, a, in the post suffix of a, you can say, or yeah, and then use that just convert them 9 into 5454, and then just do uh just print the both the part. Okay, that's about it. So should we do C? Yeah, we should do C in the next video. Okay guys, bye.